Is a professor of robotics at Edinburgh University and director for robotics and AI at the Alan Turing Institute. Very good afternoon to you. Good of you to talk to us. A man with the impressive titles like you have there. When you look at something like that, I mean, it looks primitive to me, to the uninitiated eye there. How impressive is this as a feat of technology?
Yeah, thank you, Samantha, for having me. I think one of the first things that come to mind is that these kind of challenges, grand challenges, all the way from the DARPA grand challenge, which led to the work in autonomous driving, to some of the work that happened with the grand challenges of humanoid robotics. What they do is test the boundaries of what robotics can do at the moment. Yes, you're absolutely right. It looks quite primitive compared to what humans are able to do, but just the huge scale of endurance in terms of the battery power, the robustness, the ability to get back from falling down, that is very, very impressive.
Yeah, and talk us through the other feats that these robots presumably have been able to tackle, and then presumably they can handle different gradients of terrain, they can handle other robots, other people in the way. What can they do you think?
Yeah, so that is the real challenge. So what you see here is robots that can walk, so do one thing pretty well. So walk fast, relatively fast compared to the robots of yesterday. But what you don't see here is that maybe some of the robots that are actually slower are the ones that are able to handle many other things, like lifting heavier loads, being able to detect the environment around it and react to people. So just by looking at how fast a robot can move alone is not the ultimate in terms of the goodness of that platform. So we do need robots that are able to be robust in terms of the multi-purpose use of it, but also we need systems that are don't require the need of 10 people running behind it to actually do the task it's supposed to do.
Yeah, you mentioned in your first answer, quite rightly, I mean, we've had autonomous vehicles for a while. I've met a robotic dog. There have been robots being used in car factories for many years. Why? Just tell us about the challenges of creating humanoid robots.
Great question. So it's not the first, we're not new to using robots in car manufacturing and assembly. The form factor of humanoids is very interesting because it is meant for the robots to work at the same time, at the same place, so spatially and temporally with the humans. So it is not meant to work, in a separate place or in a separate time with respect to the human workers. So the human form factor is extremely important because you want to have a system that or an environment that is built for humans and robots that can operate in this system reliably. So in a way, the humanoid form factor is really driven by the fact that we want robots and humans to coexist and help each other achieve their goals rather than replace a job.
Yeah, so what do you see, how far off are we from seeing some of those robots? I mean, that little one, I don't know if you could see it on your screen there, but that looked quite a long way off, I'd imagine, what it will evolve into. How long before we see that, and where do you see them being deployed?
Yeah, so it's a great question. So I think what you see here is just one aspect of what a humanoid form should do. That is locomote or make itself move around in a flat ground. The real challenge is what happens when these robots interact with much more complicated pieces of equipment, with other people, with other robots. So humans are very good at predicting contacts, using contacts in a way that makes us more stable and be able to exploit these contacts. So that is the next challenge for robots like these, being able to do as well as humans in terms of multi-contact interactions, being able to do finer tasks, manipulation, use sensors like skin sensors to be able to predict failure modes and react from it.
And the point of putting them in this half marathon was what exactly? Was it just to demonstrate the the endurance of the battery and the autonomy of these robots?
Exactly. So far, if you look at what are the pain points, what are the sort of, let's say, the weak link in a sort of autonomous robot working on its own, one of the key points is robustness in terms of recovery from failure. And the second bit is indeed the battery and the power capabilities. So I think this is showing those two aspects, robustness to getting up from falling down. And I think the winning robot only changed its battery 3 times. So there's a significant progress in terms of EV capabilities, battery capabilities for endurance.
All right, fascinating talking to you. Thank you very much for your time on Sky News.
Thank you.